Okay, hi. So this starts the next section on just defining probability and orienting ourselves in all the definitions related to it and some of the principles. Um, so uh, yeah, probability is not defined directly. It's defined through properties. Um, it's usually an interesting conversation. We'll save it for the class. Um, For now, we will just proceed with our definition of it. So, probability is defined axiomatically. We'll write the axioms down in a minute. We need some definitions first. So, the starting point for the whole thing, when you're talking about it, anything involving probability mathematically, is that there's an experiment, and we can list its outcomes. If we can list its outcomes, we can do problems. So we say we have an experiment, and its outcomes are naturally uncertain, or we wouldn't be doing the experiment. So we have these possible outcomes of the experiment. That's the idea there. Remember, if I confuse you, you can read the book. And then we'll define a couple things. We'll define S, capital S, to be the sample space, which is the set of all the outcomes. In this little example or picture here, I have 3 outcomes that could happen. And so I usually use little s, sometimes with subscript, for an outcome. That's a possible distinct result from the experiment, and non-overlapping with the other outcomes. So you'll see several examples in a second. And then S is the set of all of them. That's all. So straightforward so far. E is, in this example, S1, S3. So this is an example here. I'll make that clear. On an example. If E is a subset of S itself, empty set, so including S and then E is called an event. Okay, the empty set in S itself are special ones. Generally, we will not be focused on those as much, but they come up mathematically. All right, so let's look at an example. So, for example, examples. All right, so suppose we flip 2 coins, which I recognize as coin 1 and coin 2, so I do differentiate between the 2 coins. And I observe head or tails on each. Then we could write S as just the set of, or maybe I'm using the first entry here to mean the first coin. So that would be the sample space. And we could have E maybe. So E could be, so let's call this A. Just an example. E is, say, the event at least 1 head. Okay, so that's a subset. So I can also, sometimes it's more convenient, you'll see, sometimes it's not even possible really to enumerate the elements, but you have to know that it is still a subset. So this would just be HT, HH, and TH. Okay, so that's a subset, that's an event. Okay, what else could we have? Sometimes we could have an uncountable number of possible outcomes. So, for example, this is we will get into these more in the coming later in a few weeks. But we could have an example like this. B is, say, I light a match. And actually, these are, well, not to get on, light a match and let T equal time it burns. Then maybe S you would consider to be all T such that T is greater than or equal to 0. Okay, but even though you know eventually it's going to die out. In fact, because of measurement, T isn't really continuous. You're going to have some round off if you're actually measuring that, so it's not really officially, technically continuous, uncountable. But we can consider it that for our problems, and we will mainly deal with such problems when we get to continuous probability for continuous variables. So, all right, so those are two examples. Let me give you another one. So C, suppose we have, let S equal, no, so here's the experiment. Choose 5 numbers from the integers 1 to 64 without replacement. So I can't have 2 of the same. And let S be all, so without replacement, yeah, let S be all choices. Okay, so no order to this one. I could have made it order, but this one I don't want any order. Okay, so S is all combinations of these. So, sorry, is this, I have to go back to my half sheet method, I think. I was trying to write on a full sheet. So let's, so what's the size of S? So we notice, what would the size of S be? If I don't care about the order and say I'll just list, I just care which ones I pick, then it's 64. Choose 5. Okay, and suppose I let E be, suppose we have, let E be all consecutive. Quintuples. So for example, like, example would be like 3, 4, 5, 6, 7. Okay, so that's an event, right? Because that's contained in the other set. So then E is a subset. But you see, I don't want to enumerate E here. I just want to use English to specify it. So E is an event. Maybe one more.